Welcome to the School of Chemistry. My name is Abi Moses Ogo. I'll be handling you in today's class. But before we proceed, if today is your first time of visiting this channel, please make sure you click on the subscribe button and turn on the notification bell. Click on the subscribe button so that you know when we're dropping new content. It keeps you alive in the page, in the channel. Today, we'll be looking at empirical and molecular formulae. Empirical and molecular formulae is what we'll be looking at today. In our last class, we have previously studied the relative atomic mass and the relative molecular mass. We saw how we can calculate the both. Today we're going to look at how we can use this to get the empirical formulae of a substance and the molecular formulae of a substance. Now, what is empirical formulae? The empirical formula of any substance is the simplest formula of the compound. It tells you the elements present and the mole ratio in which they combine. We say the empirical formula is the simplest formula of a compound. That is just what empirical, very simple formula, the basic formula a compound can have. It tells you basically the element present in the compound and the mole ratio in which those elements combine. That's what empirical formula is. For instance, okay, before we get into that, let's see what is, on the other hand, what is molecular formula? The molecular formula is a formula that tells us all the atoms of an element that are contained in a given compound. It tells you the element present, the molecular formula tells you the element present and the number of moles in which they combine. So why this one tells you, both of them tell you the element present, the component element, but why this one tells you only the mole ratio? The molecular formula tells you the number of moles. I mean, how many atoms of each element are present? That's what the molecular formula tells you. For example, if we have these compounds, the empirical formula, and we have the molecular formula here. Now, the molecular formula and the empirical formula in some instances can be the same thing. While in other instances, the molecular formula can be a simple multiple of, say, n of the empirical formula. For instance, in the compound water, the empirical formula is H2O, and the molecular formula is H2ON. And here it will give you water, where N is equals to 1. Now, in hydrogen peroxide, the empirical formula is HO, the molecular formula is HON, and the real formula is H2O2, and N is equals to 2. In glucose, The empirical formula is CH2O. The molecular formula is going to be CH2O N, and the real formula is C6H12O6, so that N is equals to what? 6. So in some instances we say the molecular formula, the empirical formula and the molecular formula can be the same, or the empirical and the molecular formula can just be a simple multiple N of the empirical formula. Now let's look at some examples. So let's look at this example together. Determine the empirical formula of an oxide of nitrogen containing 70% oxygen and 30% nitrogen if the relative molecular mass of the oxide is 92. Deduce its molecular formula. Now, it's two things we're about to do now. We're going to calculate the empirical formula and we're also going to calculate the molecular formula, but they have given us some information. Now, also added to this information you have here is the relative atomic mass of oxygen, which is 16, and that of nitrogen, which is 14. It will always be given to you. But we have learned in our last class how we can generate these numbers with ease. So if you didn't follow that, you can go back to the previous video where we talk about easy way to remember, to record the relative atomic mass in 20 seconds. We'll have a video there for you to study. Now, the first thing we're going to do is to write the component element. And it's an oxide of nitrogen, so we're going to have O and N. Let's look at that percentage by mass given to us. The percentage of oxygen given is 70%, while that of nitrogen is 30%. Alright, this ratio, let's convert this to mole. The number of moles present in each of this percentage. For this is going to be 70. You have to divide it by the relative atomic mass of the element. So for oxygen is 16. We are dividing by 16. So if you divide it by 16, what do you get? You're going to get 4.38. While for nitrogen, divide by the relative atomic mass of nitrogen. And that's going to be 30 divided by 14. Press your calculator. What do you get? You're going to get 2.1. Now, look for the mole ratio. The mole ratio. How do you get the mole ratio? From the two moles getting, you divide by the smallest. So we have here 4.38 and 2.1. That means 2.1 is the smallest. We're going to say 4.38 divided by 2.1. And this should give you, press your calculator. This should be 2.1. And here we have 2.1 divided by 2.1. And this will give you 1. So now we'll get the whole number ratio. And here, this is going to be approximately 2:1. And what that implies is that we're going to have 1 atom of nitrogen and 2 atoms of oxygen. It's 1 atom of nitrogen. This is a nitrogen oxide. 1 atom of nitrogen, 2 atoms of oxygen. This is what this is saying. Now, for us to get the molecular formula, remember in our last class when we were getting molecular formula, we say the molecular formula is simply the sum total of all the atomic masses of the component element. So since we know the empirical formula to be NaO2, it may be a multiple N that you must add to get the relative the molecular mass of the oxide, which is what? 92. So we're going to say we get the molar mass of the empirical formula, which is going to be 14 plus 2 times 16, 2 times 16, all multiplied by n is equals to 92. This will be 14 plus 32, n equals to 92. Now add 14 and 32 together. You have 46, n equals to 92. So that n will be equals to 92 divided by 46, and is equals to 2. It's equals to 2. So that means that our molecular formula NO2 N will be equals to NO2 multiplied by 2, and this will be equals to N2O4. So this is how to go about finding the empirical formula of a substance and the molecular formula of that substance. So let's go over it again. What did we study so far? We'll try to look at what the empirical formula is, which we say is the simple formula of the compound, and what the molecular formula is, which we say is an all-encompassing formula that shows you all the elements present in their total number and their total number of moles. Now we'll see how we can calculate the empirical formula from given percentages of the elements in the compound present. We looked at it in this example and went about it by calculating the mole. We calculated the mole ratio and we got the whole number ratio, and we were able to express it as an empirical formula from which we are able to derive the molecular formula. Please, if you have any question, drop it under the comment section. And if you are yet to subscribe to this channel, please do click on the subscription button. Thank you.